All right, let's break down Khan's really amazing video. So first off, light is what's called a self-propagating wave. Self-propagating meaning it's self-sustaining, self-driving. And it does that by alternating between a changing electric field that generates a changing magnetic field, which in turn generates a changing electric field, which then generates a changing magnetic field. So it's a self-sustaining system. Changing electric fields generate those changing magnetic fields and vice versa, continuing on. So let's draw that. We're going to use red to represent electric fields and yellow to represent magnetic fields. So this is an electromagnetic wave. Notice that the yellow magnetic field is perpendicular or a 90-degree angle to the electric field. And we're going to be using lambda, that's that upside down Y symbol, to represent the wavelength, the distance from crest to crest of each of these different types of waves. And as they self-propagate, they travel in one direction, and its velocity is known as c, the speed of light, and that's a constant. That's our cosmic speed limit in our universe. Speed of a wave is equal to its wavelength times its frequency. So in this case, c is equal to lambda f, where c is the speed of light, which is 3 times 10 to the 8th meters per second. That's 300 million meters every second. Frequency is how many wavelengths pass a point in a second. So if you were to stand there and somehow count each wavelength as it passed you from crest to crest, that would be the frequency. And lambda, that upside down Y, is our symbol for wavelength. And that's the distance from crest to crest. And something cool that we can do with this equation is move it around to isolate each individual variable. So C equal to lambda F can be divided by frequency on both sides to isolate wavelength. So wavelength is equal to C divided by F. Wavelength is equal to the speed of light divided by frequency. And we can do the same thing solving for frequency. Frequency is equal to the speed of light divided by wavelength. So when we plug in some of our knowns, for example, if we know that the wavelength of a given wave is 1 meter, like on the left above radio waves, we can plug in the speed of light, which is 3 times 10 to the 8th meters per second, and divide it by that wavelength of 1 meter to find our frequency, which in this case would be 3 times 10 to the 8th hertz, 3 times 10 to the 8th waves per second. And we can do it on the other side too. What if we know the frequency? So look at the bottom, you see F is equal to 10 to the 25th hertz. If we plug that in and divide the speed of light by 10 to the 25th, we get a wavelength of 3 times 10 to the negative 17th meters. So that's a very, very small wavelength. Very, very tiny waves. The smaller the wave is, the more of them pass you every second if they're traveling at the speed of light, which all light travels at. Looking at this electromagnetic spectrum here, going from radio waves all the way to gamma waves, we'll see that on the left-hand side, we have a high wavelength with a low frequency. That's our radio waves. And then as we travel to the right-hand side of this spectrum, we're going to find that we have a low wavelength with a high frequency. That's our relationship between wavelength and frequency. And all of these different types of waves travel at the same speed, the speed of light, our cosmic speed limit.